Whoa! Sab Shed! Sab's Shed.
Just bringing you back here. I've sculpted half of the face. This is the unsculpted side. And if I turn it on the other side, hopefully you can see I've gone over the lines. And I think it looks a bit better, a little bit more defined. So there's unsculpted, sculpted, and there's the middle part. So I don't really know, because I've never done a 3D print before, but I don't really know how it's going to turn out. But anyway, that's what we've got so far. I've got to get on and do the other half now. That took quite a good amount of time, maybe 45 minutes. So another 45 minutes for that side before we get on to the next part. On we go. Right, hello again. Right, I finished. Here is the end result of all the lines, and I did a bit of smoothing on the top. So there we go. I've done that. I think that's okay for now. Right, on to the next thing. I'm going to, what am I going to do next? The next thing is to try and slice it up, I think. I'm going to do that whilst it's still solid, I think. Anyway, so let's have a go. I have rotated the head 5 degrees downwards because the model naturally looks upwards, and I want it to have a sort of, you know, straight on look while I do this. So I'm going to cut it straight away down this whole vertical plane just in front of the ear holes. So to do that, we need to go into edit and plane cut here. Click on plane cut. Is it going to work? Come on. Oh, it's working. And now at the moment the plane cut is on the horizontal line, you see. So to change it around, we click on this bit here, click and hold, and then if we move it out a bit, my computer's going all laggy. Oh, come on. Oh, I don't think it likes it. Come on. It's quite a detailed model now. Maybe I should have done this before I did all the sculpting. Anyway, you see how the circle around it has gone to these little indentations. When it does that, you can move the plane cut in increments of 5 degrees, and I want to try and see if I can get a 90 degree. It's very laggy. I may have to do this and show you at the end if it. Let's just do this bit if it continues this way. Okay, there's your 90 degrees. I want to now. Oh no, it's gone too far the other way. Well, bear with. Oh, this is going to be a bit boring. If come on. Lag. No, go that way. Oh no, this is really boring. Right, stop. I'll bring you back. This is clearly not working. But essentially I'm going to cut it vertically, and then I'm going to separate various into various shells, and oh, you'll see. Right, I'm going to have to stop. It's the next day. Here we are back on the factory floor here, and you can see all my little parts that I've cut up. It was quite tricky, and I've been playing around with things, oh God, up until about 2 o'clock last night. Anyway, I've got here the back of the head, and I've got the neck here, which I probably won't use, but it's there just in case. I've got the sort of mask, if you like, the face, which has been separated into the bottom half here and the top forehead part here, because it wouldn't fit on the print bed in one piece. Anyway, that's what I did, and in order to do that, you remember it was very laggy. I tried different things, but the one that worked was to hollow out the entire head and neck model first, and then to cut it up using the plane cut and separating the shells and so forth. To do that, it's once you've got a solid model, you just got to edit, and there's a thing here that says hollow, and then there's some parameters you can change. I stayed with the default. I think it was default anyway. It was 2mm thick walls, and that's what I came up with. What else have I got to show you? Then I thought, oh right, I've done it. I tried using a slicer program, which is a bit of software you use when you're doing 3D printing. Remember, I don't know what I'm doing here. I don't have a 3D printer, but one is coming. I've ordered one, and it's coming in the new year, which I've been saving up for. Anyway, it's all a bit of an experiment. Anyway, I tried it in the first slicing bit of software I used, which was called Cura. And a slicing software is just something that takes a model and generates something called G-code, which is some sort of code that translates your model into layers, a bit like an MRI scan, that you can imagine, layers building up the shape. Because 3D printer is basically like a very fancy hot glue gun, putting layer upon layer, but being very, very clever about it. Anyway, that's what that does. And the Cura slicer software didn't like this model. I tried it with this model first, and if I turn it around, there's the head. There were really big holes, or even troughs, all the way around here and on the other side. I don't know why, but I thought, there's problems here, and it couldn't solve the problem, and obviously that wouldn't work. So I went back into this program. I tried looking at the closed cracks again, and I tried the analysis with the inspector. Remember when we closed all the holes? There weren't any holes that I could see on here. And then I thought, well, there's some sort of problem. I don't know. I'm not an expert, so I'm sort of guessing here. So I went back to the sculpt tool up here, where you have all these different brushes, and I used this one, inflate. So I thought, all right, I'll try and make it thicker. Inflate just adds more material. Okay, let's come out of that. And I put more material around these areas. I resaved it, tried it again, same problem. I did not know what to do. So then I thought, okay, I'll try. Yeah, sorry, I had to cut off there. Anyway, I'm back now. What was I saying? Yeah, so I tried all these different things. I tried the inflate sculpt tool, but that didn't work either. So I used another bit of slicing software. This one was called Slicer, with a 3 for an E, so Slick 3er, another common one. And that has an auto repair feature, and it worked. But the consequence of that is that it generated some extra material, and I've saved it and re-imported it into the mesh mixer to show you. This is it on the left. That's my original one there. So it's generated all this material on the inside. If I spin it round, on the top you'll see there's mine. There's the one that Slicer did. So it's got all this stuff here, and it works. But what worries me is that this extra stuff might get in the way of the machinery behind. It might not, and it's irregular as well. I wanted it to be, well, I don't know, maybe regular, maybe not. Anyway, it is what it is. It sort of works. When I looked at the print, the printing stuff, it's quite thin on the edges, and I think you can probably see that. I can't really do much in terms of zooming and showing, because I think my poor little laptop is at its limit in terms of graphics here. And maybe these little red things are significant. Maybe that's all the things that are wrong with it, and for some reason I can't fix it here in Mesh Mixer, or at least I don't have the knowledge. See, this is nice and grey. This is all, you know, nasty. I don't know why. Anyway, so I need to do a bit more experimenting. It really should be, there should be more material on the edges around this mask, because I suspect that when it gets printed out, this is going to be all non-existent. Even though it looks okay, I think I can see the inconsistencies here in the model. So it looks like it's too thin. So I need to do something about that. One thought I had is to go back to the original hollowing out process, where I did it as 2mm, and make it something like 5mm. So if that's 5 of it, or even 10mm, to get a consistent all the way around look. So I might try that. Anyway, so I don't think there's much point in keeping you around just now, because the computer's a bit laggy. So I'll just continue trying a few experiments, and I'll show you what happens at the end. But I suppose it's progress. Okay, back again. Oh wow, this is taking so long. I've tried several things. I'm still here. Look, I'm moving around like Tinkerbell. What have I done? Where to start? I've tried loads of things, but I'll cut to the chase. This guy here, the bottom front of the head, this guy here, what I've tried is to re-hollow this, making it a bit thicker, which is what I've done, making it 4mm thicker, which took ages, because these are massive files in here, and it's very processor hungry. But there was loads of triangles, and then anyway I did that. It took ages, and then after that I decimated it, which is to reduce the number of triangles, and it's a lot more manageable now for a 3D printer. Then what I did, I went into the slicer programs to see if this had you know, made things any better, and I found some tricks with that as well, so I won't bore you with it all. I'll come to that later, but the upshot of it is, it looks like this is in better shape for 3D printing, at least with my not very huge knowledge about that at the moment. So that's where we are. Okay, on that one, then I did the same thing with the top of the head, which is this one here, top front, that's this boy, which fits on the top here, so that'll be glued and probably pinned somehow onto that. So that's exactly the same. I haven't done anything with the neck because I probably won't be using it. Now the other guy, the other fella, where are you? At the back of the head, which is over here. Careful now, this moves so, I'm not going to move it. Anyway, what I did with this guy, I did attempt to re-hollow it and make it thicker, but it didn't. It took about an hour, and it didn't work. It started making strange shapes inside, so I abandoned that. But what I did do is I decimated it again, reduced the number of triangles, but I did it 2 different ways. Can I show you that? Can I show you that? If I go to this, I'm not going to do it, but if I go to, let's go to the neck, right? I'm not going to do it, but I've selected the neck. Over here, if you go to, what do we need to do? I think it's edit. No, it's not. It's select. So we're going to select, and if I go to, I should zoom out really, right? If I do that, if I press Control A, you have to wait for a bit. This guy, you just see it's orange. I'm zoomed quite away, but this has been selected, the whole thing. That gives you some other options on this select menu. So I'm going to edit now, and then I go to reduce, and it takes some time to work. Bear with. So it's really processor hungry, but this is a relatively small shape, I think. So hopefully it will let me show you quickly. Right, there we go. And we can do that, and let's come back. Anyway, so here we are on the reduce panel. There are different ways you can reduce it. You can reduce the number of triangles by a percentage, by a thing called triangle budget, which is the number, if you want to specify number. And then there's another one which is called max deviation, which is a clever way of changing the number of triangles. So instead of having a regular proportion of triangles all over the model, you can allow the magic software to make some decisions where more triangles are necessary in terms of detail, it retains them. In other areas where there's not so much detail, it will make the triangles bigger or decimate the number of triangles, so you get a more intelligent sort of spread. So I've used two different ones for the face, or the mask if you like, the two pieces of the mask. I used the max deviation. I'm not going to hit it because it'll go into something else. And then down here I specified a max deviation of 0.15, so not a lot of deviation, but enough to cut the triangle count down a bit and still retain detail that I would like to retain in the mask. Of course, it could all go horribly wrong, but for now, that seems to be the level of my knowledge, such as it is. With the back of the head, it doesn't need to be as detailed, so I use the triangle budget. Oh, bum! Oh, I've told it I'm going to do it anyway. Never mind. The triangle budget is useful because I'm going to be predominantly placing that article, that object, the back of the head, into the next bit of software, the engineering software called Fusion 360, trying to get some attachment points to the mechanism, which I'm going to generate graphically as well. But Fusion 360 can't deal with these massive files with loads and loads of triangles. Its maximum is about, for a mesh, is about 10,000 triangles, so I've learned, but even then it's pushing it. So you've got to go in when you import a mesh into Fusion, you've got to watch your triangle count. So with that, I just used the triangle budget, and then here you can click on it and specify how many. So I put 10,000 there and accepted it, and that's what it did. We'll come out of that now. But so I've made some of the models thicker. I've made all of the models smaller in terms of their triangle count in two different ways. And I've tested them as far as I can at this point in both Cura and Slicer, the two Slicer bits of software that I downloaded. Again, all free software. It's been really difficult, and I still don't know if it's going to work, but that's where I am. Also, while I've got you, the Slicer software, well, the Cura does anyway, it tells you how much 3D printing filament you're going to use for your models, or estimates, gives you an estimate, and how long it's going to take, depending on the quality of the print that you do. And it estimated, you know, I mean, like between 21 hours and 2 days to do one of these models. And I was thinking, well, that is a huge amount of time, and about 1.5, 1.7 kilograms of filament. So it ain't cheap. And I thought, well, do I need this whole back piece anyway? So I might think of, I definitely need the front mask, but do I need this back piece? Can I make it out of another more economical material? So I'm going to be thinking that through. I don't know. And I've been thinking about how I attach all these things together, which I'm probably going to do old school outside of the computer 3D printing malarkey, I was going to try and do everything, but with these particular mesh, triangle heavy meshes, it's questionable how much stuff I can add to them in terms of mechanical parts. So I may do that in the shed. So anyway, the next thing I'm going to do is export these guys as STL files, I think, so I can import them into 360, Fusion 360, and start playing around with that one next. But I think this is the end of this sort of virtual modeling thing, so I hope it's been useful. It's been frustrating for me, but also quite enlightening. Yeah, funny old thing. So that's what I need to do next. Start working on bringing this into 360 so we can start building the mechanics up. And then I'm going to do some more practical work on set and costume, I think, next week. I'm working on story as well, and music. So I work in this sort of holistic fashion, really. But yeah, lots of work. But I'll crack on. Anyway, all best wishes to you all. Lovely Turk lovers, Cthulhu lovers, and any Sabbaton lovers out there as well. So this is Tron Sabbaton, wishing you all good night. Bye. Oh, hello there again. It's me, Tron Sabbaton. I've done a little bit more. This is Fusion 360, okay? And here I've imported various heads so you can see my progress. I started off with this guy here, who was the Turk head, with full turban and moustache and eyebrows. I converted it into a low poly, just to see what it was like. And then I made another version over here where I cut the neck off. Hang on, let's see if I can move in a bit. That one is slightly transparent, as you can see, but you can probably see I've cut the neck off and a bit of the top of the head, and it's not quite so low poly. And then I started doing the new virtual modeling. Now this is the fella we've just done here, or the front part of the face, which is in high detail at the moment. Hope you can see that. And then in the back, if I can zoom out again, I've got this guy here who's a complete whole low poly head that I can use. I've done a low poly version so I can use really easily because it's just for measurements really. I can use that in this environment, and just for good measure, I've brought in a low poly separate front and rear shell of the head. The rear shell is going to attach to, see if I can move it in, this fella here. In you go. So I've started modeling the mechanical construction here. There's the base of the you remember Hector, my robot Turk test bed. This is a sort of virtual representation of him so far. So I made the wooden base here. This is the turntable, the Lazy Susan turntable. These are the supports, and there's the upper stage. And I've just placed the head there at the moment. Now I've made this stage smaller than the one in real life, which is the same diameter as the base, but I've made it smaller to try and pack everything in so the head can fit more naturally on it. The only thing is we've got a wider base, so we may have to stylize the neck, which is okay. So anyway, that's what I wanted to show you. And of course it turns, look, forget the head moving around, but can you see I've made it so it's got a sort of swivel turntable, so it actually moves. The low res head is connected to that. I was just testing it, but of course the mask should turn when I do it here, but that's for another day. Anyway, I'm fed up with this graphic stuff now. Oh dear me, I want to do some acting, but never mind. I just want to make this world come alive, so onwards, ever onwards. We need to dive into the story next, I think, and do something else. Anyway, cheerio now.
Whoa! Sab Shed! Sab's Shed.